Okay, level 2 is manipulating and evaluating expressions involving positive integer exponents. So two things, actually a couple things. We've got product of powers, quotient of powers, power of a power, and zero power. Okay, the easiest one to remember is zero power. Anything to the zero power is going to be 1. It doesn't matter what it is, it doesn't matter what the base is, it's always going to be 1. So even if you look at example number D, letter D, it's got 3, a to the 5th, b to the 7th, c, but all of that is in parentheses and it's raised to the 0 power. Because all of that is raised to the 0 power, your answer for D is just 1. So it doesn't matter if it's one base or a whole group that's raised to 0, it's always going to be 1. Okay, now quotient of powers is going to be where you're going to subtract the exponents, and I'll show you why. So in the quotient of powers, if you have, let's say, have an example of, let's see, a to the 5th over a to the 3rd. We'll keep it small. Well, a to the 5th means a times a, whoops, that's not an a, 5 times 3, 4, 5. And then I have 3 a's on the bottom. So if I divide, or if I see I can simplify, I have a over a, which is just 1. A over a is 1, a over a is 1. So the only thing that I have left is a to the 2nd, or 2 a's. So when you're having division with exponents, you're going to subtract those exponents. Okay, so if we look at, let's say, example C, we're kind of working backwards here. So what we want to do is we see numbers 6 over 12. That reduces to 1 over 2. So far I have 1 and 2. Okay, now I have x to the 11th and x to the 2nd. Now you don't have to write this out every time. I think it's helpful, especially in the beginning too, so you can remember the rules. So I have 11 x's on the top, I have 2 x's on the bottom. So if I cross out 2 on the top and 2 on the bottom, I have nothing left on the bottom as far as the x's go. But that means I have 9 x's in the top left. Okay, because there's 9 in the top here and nothing is left on the bottom. And then same thing with the y's, I can do the same thing. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Okay, so one by one I got 1, 2, 3, 4, 5, and I've got 2 left, so that means I'm going to have a y to the 2nd on the top. Okay, so you can either write it out like that every single time, or you can just think about subtracting those exponents. Like I said, it might be helpful for you to write it out, especially in the beginning until you get a hang of it. Okay, the next one that we're going to do is product of powers. So we're going to look at the first example here and look at A. So when I have product of powers, okay, here I'll give you another example. We'll have a to the 3rd and, x to the 3rd and x to the 4th. So remember what this means. X to the 3rd means 3 x's. And then x to the 4th means I have 4 x's. And because these two are being multiplied together, that's the same thing as saying 3x's being multiplied together times 4x's being multiplied together, which means I have a total of 7 x's. Okay, so when I'm multiplying the common bases together, so notice that they're the same x, all you're going to do is you're going to add those exponents together. So we can write this as a plus b. Okay, now we're going to take a look at example 3a. So what I want to do is I'm going to write the like bases together. So I have -4 times 3 times x to the 5th times x to the 2nd times y to the 8th. And I know it's all being multiplied together because if I don't see an operation in between two variables, I know it's going to be multiplication. So now I'm going to put together what I know. -4 times 3 is -12. And I'm going to write this out again. This is something that you don't have to do. I just think it's helpful, especially in the beginning. 2, 3, 4, 5, and then I have another 2. And then the y's, I have 1 y and then 8. 1, 2, 4, 5, 6, 7, 8. Okay, so I wrote out 8 y's and then that 1 y. So now I'm just going to add up and count how many x's I have. I still have the negative 12. And I'm going to have x to the 7th because there are 7 x's, and y to the 9th because there are 9 y's. Okay? Alright, the last example that I think is the harder one. It's called power to a power. You won't have to remember the names of these, it's just what we call them. So, alright, so power to a power. Here's an example. So, let's do x to the 2nd to the 4th. Okay, if you remember, x to the 2nd means x times x. Okay, that's what this 2 means. Now this 4 means I have x times x 4 times. Okay, so if again, this is all being multiplied together here. So if I count 1, 2, 3, 4, 5, 6, 7, 8, you're going to get x to the 8th. Okay, so that's what we call power to a power. If you notice, that's just multiplication between those two powers. So it's going to be x to the 8th. I don't have to write it all out. Or we can say x a times b for your example. Okay, so let's take a look at b. Now, you can use that shortcut and rule 3 times 4 and 4 times 5. I personally don't like that because a lot of the times it will screw you up as we get harder examples. So I'm going to write this out 4 times. So I have a to the 3rd, b to the 5th. A to the 3rd, b to the 5th. So now I'm going to put the a's together. So I have a to the 3rd, a to the 3rd, a to the 3rd, a to the 3rd, and then 4b to the 5ths. So here I have a to the 3rd 4 times. So I have 3, 6, 9, 12. And then for the b's, I have 4b, so 5, 10, 15, 20. Okay, let's try some harder examples. Okay, so we're going to take one chunk at a time. So we're going to work with this chunk first. Okay, I see I have parentheses and then a 2, so I'm going to write this thing twice. So I have negative 3 x to the 4th, y to the 8th. And I'm going to just keep this off to the side for a second. Okay, so I'm going to put together what is similar. So I have negative 3 times negative 3, x to the 4th, x to the 4th, y to the 8th, y to the 8th. I have 9 x to the 8th, y to the 16th. Again, you can by all means distribute this too and say negative 3 squared and then multiply all of those. It gets tricky when we get to level 3s. So that's why my suggestion is to write it out and then match everything up. Okay, and then I've got this one off to the side. X to the 11th, y to the 0. So again, you remember y to the 0 is always going to be 1, so I can change that now. That looks like a 0. So there we go. So this is just going to be multiplied by 1. Okay, I'm going to match up what I have in common. So 9 times 7, x to the 8th, x to the 11th, y to the 16th, and now I could multiply by 1 out in front. It doesn't really change anything. So 1 times 9 times 7 is 56. No, that's not right. 54. Whoops, sorry. And then x to the 19th and y to the 16th. X to the 19th because I have 8 and then 11. So I'm going to add those together and make it 19. Alright, last one, hang in there. Okay, when you have a fraction and it's raised to an exponent, simplify within the fraction first and then apply the exponent. So I see negative 15 and 27. That's going to reduce to, let's see, 5 goes into both of them. So I'm sorry, 3 goes into both of them. So negative 5 and 9. So I have negative 5, 9. And then I have c to the third and c down here. So that means I'm going to have 2 left on top because one of them will cancel. And then d to the fifth and d to the second. So if I have 5 d's on top and 2 on the bottom, 2 of them will simplify and I'll have 3 left on the top. Okay, and now I'm going to apply that squared. So I'm going to write it twice. 5 c to the second d to the third over 9 times negative 5 c to the second d to the third over 9. So remember how we multiply fractions? Straight across. So I'll have negative 5 times negative 5, c to the second, d to the third, over 9 times 9. So I'm going to have 25 c to the fourth, d to the sixth, over 81. And 25 over 81 can't simplify, so that is your final answer. So again, the powers and the tricks, they're great. I just think it's easier, especially as you get more complicated problems, to write it all out.